Hello, in this lecture we'll answer two questions. In the first question, we'll find out the area of this square ABCD. In the second question, we'll find out the size of this angle theta, that is a triangle DOE. So we'll start with the first question. In the drawing, we have a square ABCD. Line segment AP equals to 5 units. Line segment BP equals to 3 units. Line segment CP equals to 6 units. And our mission is to find out the area of this square ABCD. Okay. So first of all, we'll do a construction. We'll extend side CD of the square by a straight line. And from point P, we will go perpendicular on the extended side DC. Structurally, this angle is equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point P in the extended DC as N. We'll do another construction from point B. We draw perpendicular on PN. From point B, we draw perpendicular on PN. So here, this angle is equal to 90 degrees, and this angle is also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. We define side BM as A. The length of side BM equals to A units according to our definition. We define side PM as B. PM equals to B units according to our definition. In the next step, we'll implement the Pythagoras theorem on the right triangle PMB. On the right green triangle PMB. This right green triangle. So, according to the Pythagoras theorem, the right triangle PBM, this green right triangle, by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the green triangle is PB, therefore the square of the hypotenuse is PB squared. And it must be equal to PM squared plus BM squared. Repeat again, according to the Pythagoras theorem, in the green right triangle PBM, PB squared equals to PM squared plus BM squared. Okay, so here PB equals to 3 units according to what is given as the question. Therefore, PB squared is 3 squared, that is 9. and it is equal to PM square. PM equals to B, therefore PM square is B square plus BM square. BM is equal to A, therefore BM square is A square. So, in conclusion, we found out that according to equation number 1, A square plus B square equals to 9. Okay, we know that all the angles inside a square are right angles, so in this first square A, B, C, D, we have 4 right angles. So this angle equals to 90 degrees, this angle is also equals to 90 degrees. This angle equals to 90 degrees, and this angle equals to 90 degrees. TC is one side of square ABCD, therefore it is absolutely a straight line. And then when we extended the straight line DC by a straight line, we got line segment DN. When we extend a straight line by a straight line, the result that is DN must be also a straight line. Therefore DN is a straight line. I write it down. DN is a straight line. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DN at point C? We have this angle that is equal to 90 degrees plus this missing angle. The missing angle must be also equal to 90 degrees. In order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, this angle must be equal to 90 degrees. So inside quadrilateral B, M, and C, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in this quadrilateral to 360 degrees. This angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so we found out that quadrilateral BMCN is 4 right angles, therefore it is a rectangle. Okay. We focus on the segment line AM. In the segment line AM, we focus on the lower side of the segment line AM at point B. Here, this angle is equal to 90 degrees, and this angle is also equal to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. Therefore, angle ABM equals to 180 degrees. Angle ABM is equal to 180 degrees. Okay. And any angle that is equal to 180 degrees must be a straight line. Therefore, angle ABM is a straight line. Because it is equal to 180 degrees. A straight line. Angle ABM is a straight line. If angle ABM is a straight line, then line segment ABM is also a straight line. And if line segment ABM is a straight line, then AM is also a straight line. AM is a straight line. AM is a straight line. AM is a straight line. AP is a straight line, it is given as the question. PM is part of perpendicular PN, therefore it is absolutely a straight line. Therefore, shape APM, this shape is a right triangle. Okay, shape APM is a right triangle. Is a right triangle. Therefore, we will implement the Pythagoras theorem on the right triangle, triangle APM. Okay, in the right triangle, triangle APM, by PT is evaluation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AP square must be equal to PM square plus AM square. Okay. Repeat again. In the right triangle, triangle APM, here, this right triangle, triangle APM, AP square equals to PM square plus AM square. We define the side length of square ABCD as x, so all of its sides will be equal to x, of course. So, repeat again. In the right triangle, triangle APM, AP square equals to PM square plus AM square. Okay, so here AP square AP equals to 5 units according to what is given as the question. Therefore, AP square equals to 5 square, that is 25, and it is equal to PM square. PM equals to B, therefore PM square is B square plus AM square. What is the value of AM? It is very easy to see from the drawing that AM equals to X plus A. Again, AM equals to X plus A. Therefore, AM square will be equal to X plus A square. So in conclusion, found out that according to equation number 2, 25 equals to B square plus A plus A square. Here we'll open the brackets on this side of equation number 2 and we get that according to equation number 2, (25) equals to B square plus X plus A square. X plus A square equals to X square plus A square plus 2XA. In this equation, equation number 2, we have B square plus A square. And according to equation number 1, we found out that B square plus A square equals to 9. Therefore, we substitute B square plus A square in this equation, equation number 2, by 9. And we get that 25 equals to 9 plus X square plus 2AX. Here we subtract 9 from this equation, equation number 2, and we get that according to equation number 2, 25 minus 9 is 16. That is equal to X square plus 2AX. Here we subtract X square from this equation, equation number 2, and we get that according to equation number 2, 16 minus X square equals to ax. So here we divide this equation number 2 by 2x, and we get that according to equation number 2, a is equal to 16 minus x squared over 2x. Okay, here, I write it here also. According to equation number 2, we found out that a equals to 16 minus x squared over 2x. So we have the value of a in terms of x. Okay. We have already found out that quadrilateral BMCN has 4 right angles, therefore quadrilateral BMCN is a rectangle. Quadrilateral BMCN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say BM equals to CN. BM equals to CN. BM equals to A, so I can write here that BM equals to A. And from this equation, A equals to BM equals to Cn, we will derive that Cn is also equals to A. Cn equals to A. Here Cn equals to A. Likewise, according to the symbol that the opposite sides of a rectangle are equal to each other, we get that BC is equal to Mn. BC is equal to Mn, but BC equals to x according to our definition. And from this equation x equals to BC equals to Mn, we will derive that Mn is also equals to x. Mn is also equals to x. So here we can write down that Mn equals to x. So in the next step, we'll implement the Pythagoras theorem on the right big triangle, the right green big triangle, triangle P and C. On the right big triangle, triangle P and C, green triangle. Again, by PT is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PC, therefore the square of the hypotenuse is PC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to Pn squared plus Nc squared. Repeat again, according to the Pythagoras theorem, in the right green triangle P and C, PC squared equals to Pn squared plus Nc squared. Okay. So here PC equals to 6 units, therefore PC square will be equal to 36. And it is equal to Pn square. What is the value of Pn? It is very easy to see from the drawing that Pn equals to B plus X. This is B and this is X. Pn equals to B plus X. Therefore Pn square is B plus X square. Plus NC square. NC equals to A, therefore NC square is A square. So in conclusion, we found out that according to equation number 3, 36 equals to B plus X square plus A square. Here we'll open the brackets on this side of equation number 3 and we get that according to equation number 3, 36 equals to B plus X square equals to B square plus X square plus 2 times BX plus A square. Okay. In this equation, we have B square plus A square, and according to equation number 1, B square plus A square equals to 9. Therefore, we substitute B square plus A square by 9 in this equation, equation number 3, and we get that according to equation number 3, 36 equals to B square plus A square is 9 plus X square plus 2BX. Here we subtract 9 from this equation, equation number 3, and we get that according to equation number 3, 36 minus 9 is 27, that is equal to X square plus 2BX. Here we subtract X square from this equation, equation number 3, and we get that according to equation number 3, X square 27 equals to X square plus 2BX, so 27 minus X square equals to 2BX. Here we divide this equation, equation number 3 by 2X, and finally we will get that according to equation number 3, B equals to 27 minus X square over 2X. So here we have the values of A and B in terms of X. Repeat again, we have the values of A and B in terms of X. According to question number 1, we found out that A square plus B square equals to 9. We've already found out that A equals to 16 minus X squared over 2X. And if we square this expression, we get A squared plus b squared. B, we already found out that b equals to 27 minus x squared or 2x, and if we square this expression, we get b squared, and according to the equation number 1, it is equal to 9. Here we'll open the brackets of those two expressions, and we'll get that according to equation number 1, 16 minus x squared squared is equal to 16 squared, that is 256, plus x squared squared is x to the power of 4, minus 2 times 16 is minus 32, times x squared. All divided by 2x squared, that is 4x squared. But here we have 4x squared in the denominator of the second expression, therefore we can add the numerator of the first expression to the second expression. We do it now, and we get that 27 minus x squared squared, it is equal to 27 squared, that is 729, minus 2 times 27 is minus 54, times x squared, and x squared is x to the power of 4. And it is equal to 9. Okay. So here 256 plus 729 is equal to 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, minus 32x squared minus 54x squared is minus 86x squared. Now we multiply this equation number 1 by 4x squared, and we get that 4x squared times 9 is 36x squared. So here we subtract 36x squared from this equation number 1, and we get that according to equation number 1, two times x to the power of 4 minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. So here we define x squared as z. If x squared equals to z, it means that x to the power of 4 will be equal to z squared. So this expression in total will be equal to 2z squared minus 122, x squared is z, so we substitute x squared by z, plus 985 equals to 0. So we have a quadratic equation. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of a quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. In our specific quadratic equation, the coefficient A equals to 2, the coefficient B equals to minus 122, and the coefficient C equals to 985. So I write it down, repeat again, in our specific quadratic equation, the coefficient A equals to 2, the coefficient B equals to minus 122, and finally the coefficient C equals to 985. The variable that we are looking for is Z, so here Z equals to minus B, B is minus 122, therefore minus B is minus 122, that is plus 122 plus minus square root of B square. B is minus 122, therefore B square is minus 122 square, that is equal to 14,884 minus 4 times A is 2, so minus 4 times A is minus 8, times C is 985, so minus 8 times 985 is 7,880 over 2A. A is 2, so 2A is 2 times 2, that is 4. So here Z equals to 122 plus minus 14,884 minus 7,880 is 7,004, so we left only inside the root only 7,004, all divided by 4. So here we get that Z equals to 122 plus minus the square root of 7,004 is 83.6899 over 4 over 2A is 4. So here we have two solutions that are possible for Z. The first solution for Z is that Z equals to 122 plus 83.6899 over 4. 182 plus 83.6899 is equal to 205.6899, and if we divide it by 4, we get that Z equals to 51 point here 205.6899 over 4 is equal to 51.4224, but Z equals to X squared, that is equal to 51.4224. Here we take out of this equation and we get that if X squared equals to 51.4224, then the square root of this number will give us the value of X. So here X will be equal to the square root of 51.4224. That is actually equals to X equals to 7.17 units. Actually, X here, AB that is equal to X cannot be equal to 7.17 units. I'll explain why. Here we have the right triangle, triangle APM. Triangle APM is a right triangle with hypotenuse AP that is equal to 5 units. And we know that the hypotenuse is the biggest side in any right triangle. Therefore, AP is greater than AM in triangle APM. AP is greater than AM in triangle APM. So if AP is greater than AM, let alone that AP will be greater than AB that is part of AM. So we can write down that AP, that is the hypotenuse of the right triangle APM, is equal to 5 units, and it is greater than AB that is equal to X. Again, AP, that is the hypotenuse in triangle APM, is equal to 5 units, and it must be greater than AB that is equal to X. Okay? So from this equation, from this inequality, we get that X is less than 5 units. X must be less than 5 units. Okay, X must be less than 5 units, but according to the solution to the quadratic equation, we actually found out that X equals to 7.17 units, that is greater than 5 units. Therefore, we have a contradiction. Due to the contradiction, we cancel the possibility that X equals to 7.17 units. And we left only in the second solution to the quadratic equation that Z is equal to 122 minus 83.6899 over 4. And 122 minus 83.6899 is equal to 38.301. Let me check it again. We have 122 minus 83.6899. So it is actually equals to 38.3101. Okay. So, and if we divide it by 4, we get that Z equals to 9.5775. Okay, Z that is equal to X squared according to our definition, it is equal to 9.5775. But here Z equals to X squared, but X squared is the area of square ABCD, that is the area that we are looking for. Therefore, we can write down that the area of square ABCD is equal to X squared, and X squared equals to Z according to our definition, that is equal to 9.5775 square units. And if we take a root from X squared, we get the value of X. So the square root of this number, it is equal to 3.09 units, and indeed it is shorter than the hypotenuse AP. Here AP equals to 5 units and X equals to 3.09 units. Therefore, it is shorter than AP. Okay, so the answer to the question is that the area of square ABCD equals to 9.5775 square units. We finished with the first question. In the next step, I will present to you the second question. In the drawing, we have a right triangle, triangle ABC. This angle equals 90 degrees. Inside the right triangle ABC, we have a circle. Inside the circle, we have triangle DOE. And we are looking for this angle, angle theta. Okay, and we also know that AD equals to EC, and we know also that DE is twice as long as EC, and DE is also twice as long as AD. Okay, and our mission is to find out the size of this angle, angle theta. So here we defined line segment DE as 2A. Here I write it down. According to our definition, DE equals to 2A. And according to what is given us in the question, AD equals to CE, and it is equal to DE over 2. But according to our definition, DE equals to 2A, so can substitute DE by 2A. 2A over 2 is A. So in conclusion, we found out that AD equals to CE, that is equal to A. That is to say, AD equals to A, and CE is also equals to A according to this equation. Then actually have also rule number 4 here. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. Here point O is the center of the circle. From point O we draw perpendicular on chord CD. Therefore, the perpendicular OM bisects chord CD. That is to say, CM equals to MD, and CM equals to CD over 2, and MD is also equals to CD over 2. Can implement rule number 4 in our drawing. Why? Because in our drawing, from point O, we draw perpendicular on chord DE. Again, from point O, we draw perpendicular on chord DE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. According to our construction, we define the touching point of the perpendicular from point O to DE as T. So according to rule number 4, DT equals to TE. I write it down. Here, DT is equal to DT equals to TE, and DT equals to DE over 2, and TE is also equals to DE over 2. Okay, so here according to rule number 4, DT equals to TE equals to DE over 2. But D equals to 2A, so we substitute DE by 2A. 2A over 2 is A. So in conclusion, we found out that, according to rule number 4 of course, in conclusion we found out that dt equals to te and it is equal to a. Here dt equals to a and te is also equals to a. Okay. In the next step, we'll define the point of tendency of tangent AB with this circle as point M. We'll define the point of tendency of tangent BC with this circle as point N. We'll join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle. We define the radius of this circle as R or capital R, so OM equals to capital R. We have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. This angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R according to our definition. And again, we have the radius ON that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees and this angle will be also equal to 90 degrees. So inside quadrilateral MOBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, therefore the fourth angle, this angle, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, therefore quadrilateral MOBN that has 4 right angles is a rectangle. So I write it down, quadrilateral MOBN that has 4 right angles is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. But MO equals to R. So you can write here that MO equals to R. And from this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. BN is also equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that in rectangle MOBN, this rectangle, MB equals to ON. MB equals to ON. But here ON equals to R. We already found out that ON equals to R. And from this equation, MB equals to ON equals to R, we derive that MB is also equals to R. MB is also equals to R. Here MB equals to R. Okay, so we actually found out that quadrilateral MOBN is not a rectangle but a square. So I write it down, quadrilateral MOBN is a square because all of its sides are equal to R. Okay. In the next step, I will present to you a new rule, rule number 10, according to to rule number 10, if we have this circle and we have the external point P, from the external point P we have tangent PA, that is tangent to the circle at point A. We have the straight line that intersects with the circle at point B and at point C. So this is the data that has been given to us. Then according to rule number 10, the following equation is true, that PA squared equals to PB times PC. Again, PA squared equals to PB times PC. We can implement rule number 10 in our drawing. Why? Because here, if we focus at point C, the external point C, from the external point C, if we focus on the external point C, we have tangent Cn, and we have the straight line that intersects with the circle at point E and then point D. Therefore, according to rule number 10, we get that Cn squared equals to CE times CD. I'll repeat again. Here, we implemented rule number 10 in the external point C. According to rule number 10, we get that Cn squared equals to Ce times Cd. So Cn squared equals to CE. CE equals to A, therefore we substitute CE by A times CD. It is very easy to see from the drawing that CD equals to A plus A plus A, that is 3A. So we substitute CD by 3A. So in conclusion, we found out that according to rule number 10, Cn squared equals to A times 3A. So Cn squared equals to A times 3A is 3A squared. Here we take a root out of this equation and we get that Cn equals to the square root of 3A squared. The square root of 3A squared, the square root of A squared is A, and the square root of 3 is the square root of 3. So in conclusion, we found out that the square root of 3A squared is square root of 3 times A. So you can write down here that Cn equals to the square root of 3 times A. Likewise, we'll focus on the external point A. On the external point A, according to rule number 10, here, from the external point A, we have tangent AM, and we have a straight line that intersects with the circle at point D and at point E. Therefore, we can implement rule number 10 in the external point A. And we get that according to rule number 10, AM squared equals to AD times AE. AD times AE. Okay. I'll repeat again. According to rule number 10, if we focus on the external point A, we get that AM squared equals to AD times AE. Okay, so AM squared equals to AD. AD equals to A, so substitute AD by A times AE. What is the value of AE? From the domain it is very easy to see that A equals to A plus A plus A, that is 3A. So substitute AE by 3A. So in conclusion, I found out that AM squared equals to A times 3A. So AM squared equals to A times 3A is 3A squared. We take out of this equation and we get that AM equals to the square root of 3 times A. Always I found out that AM equals to the square root of 3 times A. In the next step I will copy the right triangle ABC in a new page and we'll analyze triangle ABC. So here we have triangle ABC. The right triangle ABC. What is the value of the hypotenuse AC? AC equals to A plus A plus A plus A, that is 4A. What is the length of AB? It is very easy to see from the domain that AB equals to the square root of 3 times A plus R. Again, AB equals to the square root of 3 times A plus R. Likewise, what is the length of BC? It is very easy to see from the domain that BC is also equals to the square root of 3 times A plus R. Okay, so here we actually so this is the right triangle ABC that I copied from the original domain. The right triangle ABC, side AB equals to side BC because both sides are equal to square root of 3 times A plus R. And we have the rule that in front of equal sides in the triangle, there are equal angles. That is to say, those two angles that are located in front of equal sides must be equal to each other. So if we define this angle as theta, then the other angle must be also equal to theta because of the fact that they are equal to each other. And because of the fact that this is a right angle, this angle equals to 90 degrees, the other two angles must be also equal to 90 degrees in order to complete the sum of the angles in this triangle 280 degrees. Those two angles must be equal to 90 degrees because 90 degrees plus 90 degrees it is 180 degrees. So that is to say, we found out that theta plus theta must be equal to 90 degrees. Theta plus theta must be equal to 90 degrees. Theta plus theta is 2 theta and 2 theta equals to 90 degrees. We divide this equation by 2 and we get that theta equals to 90 degrees over 2, that is 45 degrees. So I found out that theta equals to 45 degrees. You can write here that theta equals to 45 degrees. So in the right triangle ABC, it is very easy to see that cosine 45 degrees is equal to BC over AC. Is equal to BC over AC. Again, cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R over AC. AC equals to 4A, so we substitute AC by 4A. And we know that cosine 45 degrees is 1 over square root of 2, so we substitute cosine 45 degrees by 1 over square root of 2, and it is equal to square root of 3A minus R over 4A. Here we will multiply this equation by 4A, and we will get that 4A over square root of 2 is equal to square root of 3 times A minus R. So here we substitute 4 by 2 times 2, and we get here that two times 2 times A over square root of 2 equals to square root of 3 times A minus R. So here we substitute 1, 2 by square root of 2 times square root of 2, and we get that here we have 2 times 2, and we substitute 2 by square root of 2 times square root of 2 times A over square root of 2, that is equal to square root of 3 times A minus R. So here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we are left only with 2 times square root of 2 times A, that is equal to square root of 3 times A minus R. So here actually here we have it is square root of 3, BC equals to square root of 3 times A plus R. Okay, it is equal to square root of 3 times A plus R. It is plus R. So here we subtract square root of 3A from this equation, and we will get that R equals to 2 times square root of 2 times A minus square root of 3 times A. So R equals to, we will take A as a common factor out of those two expressions. What is left from 2 times square root of 2 times A, after we took from it A as a common factor, what is left is actually 2 times square root of 2. And what is left from minus square root of 3 times A, after we took from it A as a common factor, what is left is actually minus square root of 3. So in conclusion, we found out that the radius of the circle is equal to A times 2 times square root of 2 minus square root of 3. In the next step, I will copy the right green triangle DOT, and in your page we will analyze triangle DOT. Okay. Here point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to capital R. So this is the right triangle DOT that I copied from the original drawing. In this right triangle DOT, it is very easy to see that cosine theta equals to dt over dO. Again, cosine theta equals to dt over dO. So I write it down in the right triangle DOT. It is very easy to see that cosine theta equals to dt over dO. dt equals to a, so we substitute dt by a. dO equals to r, so we substitute dO by r. But we have already found out that r equals to a times 2 times square root of 2 minus square root of 3, so we substitute r by a times 2 times square root of 2 minus square root of 3. Okay. So here we have a in the numerator and a in the denominator, so a will get cancelled. And finally we found out that cosine theta is equal to 1 over 2 times square root of 2 minus square root of 3. Okay, our mission is to find out the value of theta itself. In order to find out the value of theta itself, we will operate the opposite function of cosine, that is cosine minus 1, on the result. That is this expression. In this way, we will get the value of theta itself. Repeat again, we operate the opposite function of cosine, that is cosine minus 1, on the result, that is 1 over 2 times square root of 2 minus square root of 3. In this way, we will get the value of theta itself. Here we operated the opposite function of cosine, that is cosine minus 1, on the result, and in this way we get the value of theta itself. So the value of this expression, the opposite function of cosine, that is cosine minus 1, if we operate it on the result, that is this expression, we will get that theta itself, this expression, equals to 24.203 degrees. And this is the value of theta. Okay, so we found out that theta equals to 24.203 degrees. I repeat again, we found out that the side of this angle theta, is equal to 24.203 degrees. We finished with the second question. In the next step, I will summarize the lecture and start, of course, with the first question. So in the drawing we have square ABCD. We know that line segment AP equals to 5 units, line segment PB equals to 3 units, and line segment PC equals to 6 units. And our mission is to find out the area of this square ABCD. Okay, so we did a construction. We extended side DC of square ABCD by a straight line, and from point P we drew perpendicular on the extended DC. Again, from point P we drew perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and the extended DC as N. Then we did the second construction. From point B, we drew perpendicular on PN. Again, from point B, we drew perpendicular on PN. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point B and PN as M. Okay, then we define side PM as B, and we define side BM as A. Then we implemented the Pythagoras theorem on the right green triangle, triangle PBM. On this right green triangle, triangle PBM. According to the Pythagoras theorem, we get that PM square, PB square, the square of the aperture, equals to PM square plus MB square. Repeat again, in the right triangle, triangle PBM, according to the Pythagoras theorem, PB square equals to PM square plus PM square. PB equals to 3, therefore PB square is 3 square. And that is 9. And PM equals to B, therefore PM square is B square. BM equals to A, therefore BM square is A square. So in conclusion, we found out that according to equation number 1, 9 equals to A square plus B square. We also know that all the angles inside the square are right angles, so those 4 right angles in square ABCD are right angles. And here we did a construction. We extended side DC by a straight line of square ABCD. DC is one side of square ABCD, therefore it is absolutely a straight line. So DC is a straight line, and when you extend a straight line by a straight line, the result is DN. It must be also a straight line. So DN is a straight line. So if you focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of DN at point C? We have this angle that is equal to 90 degrees, plus this is the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. So this angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, this angle must be also equal to 90 degrees. Okay, so here inside quadrilateral BMCN we have 1, 2, 3 right angles. Those 2 angles are right angles according to our construction. So the sum of 3 right angles is 270 degrees, therefore the fourth angle must be also equal to 90 degrees. In order to complete the sum of the angles in quadrilateral BMCN to 360 degrees, this angle must be equal to 90 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral BMCN we have 4 right angles. Therefore quadrilateral BMCN is a rectangle. Then we focused on the lower side of segment line AM. We focus on the lower side of segment line AM. On the lower side of AM at point B, This angle equals to 90 degrees, this angle equals to 90 degrees, so the sum of the angles is 90 degrees plus 90 degrees is 180 degrees. So we know that angle ABM is equal to 180 degrees. Okay, angle ABM equals to 180 degrees, and therefore if angle ABM equals to 90 degrees, it means that angle ABM is a straight line. This is exactly the definition of a straight line. If any angle is equal to 180 degrees, it must be a straight line. Therefore, angle ABM is a straight line. If angle ABM is a straight line, then line segment ABM is also a straight line, and if line segment ABM is a straight line, then line segment AM is also a straight line. So line segment AM is a straight line. Here PAP is also a straight line according to what is given as the question, and PM is part of a perpendicular that is absolutely a straight line. Therefore, we found out that shape APM, this shape is a right triangle. Okay, shape APM is a right triangle, and therefore we can implement the Pythagoras theorem on the right triangle, triangle APM. On the right triangle, triangle APM, according to the Pythagoras theorem, we get that AP square equals to PM square plus AM square. I repeat again, according to the Pythagoras theorem, AP square equals to PM square plus AM square. AP equals to 5, therefore AP square is 5 square, that is 25. And it is equal to PM square. PM is B, therefore PM square is B square. Okay, and AM is X plus A, therefore AM square is X plus A square. So in conclusion, we found out that according to equation number 2, 25 equals to B square plus A plus X square. We open the brackets on this side of equation number 2 and found out that 25 equals to B square plus X plus A square is X square plus A square plus 2 times X times A. In this equation, equation number 2, we have B square plus A square, but according to equation number 1, B square plus A square equals to 9. So we can substitute B square plus A square by 9 in this equation, equation number 2. We did it, and we got that 25 equals to 9, that is B square plus A square, plus X square plus 2AX. Here we subtracted 9 from this equation, equation number 2, and found out that 25 minus 9 is 16. So 16 equals to X square plus 2AX. We subtracted X square from this equation, equation number 2, and found out that 16 minus X square equals to 2AX. Here we divided this equation, equation number 2 by 2x, and finally we got that A equals to 16 minus X square or 2x. So we got the value of A in terms of X. Here we found out again that A equals to 16 minus X square over 2x. Okay? We already found out that quadrangle BMCN is 4 right angles, therefore quadrangle BMCN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say BM equals to CN. BM equals to CN. But according to our definition, BM equals to A. BM equals to A, so from this equation A equals to BM equals to CN, we will derive that CN is also equals to A. Here CN equals to A. Likewise, according to the sum rule that the opposite sides of a rectangle are equal to each other, we will get that CN equals to MN. CN equals to MN. MN, or here BC is equal to MN. It is BC that is equal to MN. Again, BC is equal to MN. BC equals to MN. But according to our definition, BC equals to X. So we can write here that BC equals to X. And from this equation, X equals to BC equals to MN, we derive that MN is also equals to X. Here MN equals to X. Then we implemented the Pythagoras theorem on the right big triangle, triangle PCN. This right green triangle. According to the Pythagoras theorem, PC square equals to Pn square plus Cn square. I repeat again, the right triangle PCN. PC square equals to Pn square plus Cn square. PC equals to 6, therefore PC square is 6 squared, that is 36. And it is equal to Pn square. Pn equals to b plus x, therefore Pn square is b plus x square, plus Cn. Cn is a, therefore Cn square is a square. So in total, in conclusion, we found out that 36 equals to b plus x square plus a square. Here we open the brackets on this side of equation number 3 and found out that according to equation number 3, 36 equals to b square plus x square. B square plus x square equals to b square plus x square plus 2bx plus a square. Here we have a square plus b square according to equation number 1, a square plus b square equals to 9. So we substitute a square plus b square in equation number 3 by 9. And found out that 36 equals to 9 plus x square plus 2bx. Here we subtracted 9 from this equation number 3, and we found out that 36 minus 9 is 27, that is equal to x square plus 2bx. Here we subtracted x square from this equation number 3, and we found out that 27 equals to x, 27 minus x square equals to 2bx. Here we divided this equation number 3 by 2x and found out that b equals to 27 minus x square over 2x. So we got the values of a and b in terms of x, and then we actually have equation number 1 that states that a square plus b square equals to 9. We have already found out that a equals to 16 minus x square over 2x, so if we square it, we get the value of x square plus b square. B equals to 27 minus x square over 2x, so if we square it, we get the value of b squares, and it is equal to 9. So this is question number 1 that says that a square plus b square equals to 9. Then we open the brackets of those two expressions on this side of question number 1 and found out that 16 minus x squared equals to 16 squared, that is 256, plus x squared is x to the power of 4, minus 216 is minus 32 times x squared. And here we have the same denominator on both expressions, therefore we can add the numerator of this expression with the numerator of this expression. So we did it and we got that 27 minus x squared equals to 27 squared, that is 792, minus x squared plus x squared is x to the power of 4, minus 2 times 27 is minus 54, and so this expression in total will be equal to minus 54 x squared, and it is equal to 9. All divided by 2x squared, that is 4x squared. Here, 256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. And we have minus 32x squared minus 54x squared is minus 86x squared. And it is equal to, here we multiplied this equation number 1 by 4x squared. 4x squared times 9 is 36x squared. Then we subtracted 36x squared from equation number 1, and found out that 86x squared minus 36x squared is minus 122x squared. So in conclusion, found out that according to equation number 1, 2 times x to the power of 4 minus 122x squared plus 985 equals to 0. Here we defined x squared as z. So if x squared equals to z, it means that x to the power of 4 will be equal to z squared. So in total, this expression will be equal to 2z squared plus 122x squared is z, so we substitute x squared by z. plus 985 equals to 0. We got this quadratic equation here, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. Here, those are the three coefficients of our specific quadratic equation. So we put the data inside the formula for x, and we found out the value of z because z equals to x. So z equals to minus b, b is minus 122, therefore minus b is minus 122, that is plus 122, plus minus b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985. So minus 8 times 985 is minus 7,880. All divided by 2a. A is 2, so 2a is 2 times 2, that is 4. So here we got that z equals to 122 plus minus 14,184 minus 7,880 is 7,004. So inside the square we left only with, inside the root we left only with 7,004 divided by 4. So here we found out that z equals to 122 plus minus the square root of 7,004 is 83.6899 divided by 4. So here we have two solutions that are possible for z. The first solution for z is that z equals to 122 plus 83.6899 over 4. So 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that z equals to 51.4224. So what is z? Z is x squared according to our definition, and found out that it is equal to, so x squared equals to 51.4224. So we'll take a root out of this equation, and we get that x equals to the square root of 51.4224, and the square root of 51.4224 is 7.17 units. Found out that x equals to 7.17 units. Okay, here this AB that is equal to x, it is equal to 7.17 units. But it is impossible that x equal to 7.17 units. Why? Because if we focus on the right triangle APM, the hypotenuse AP equals to 5 units. And the hypotenuse is the biggest side in any right triangle, therefore AP in triangle APM, in the right triangle APM, must be greater than AM. So if AP is greater than AM, let alone that AP will be greater than AB that is part of AM. So here we found out that AP that is equal to 5 is greater than AB that is equal to x. Okay, again we found out that AP that is the hypotenuse that is equal to 5 units, it is greater than AB that is equal to x. So from this inequality we derive that that x is less than 5 units. From this inequality we derive that x must be less than 5 units. But according to our solution, x equals to 7.17 that is greater than 5 units. So we got a contradiction here. Due to the contradiction, we cancel this possibility to the solution of the quadratic equation, and we will focus on the second solution to the quadratic equation, that z equals to 122 minus 83.6899 over 4. 122 minus 83.6899 is 33.3101, and if we divide it by 4, we get the value of z, that is 9.5775. But what is z? Z is x squared, that is equal to 9.5775. But x squared, it is exactly the value that we are looking for, because x squared is the area of square ABCD. Okay, that is the value that we are looking for. So we found out that the value, the area of square ABCD is equal to x squared, and it is equal to z. That is to say, the area of square ABCD equals to 9.5775 units. Then we take a root, we can take the square root of x squared, and we found out that x equals to 3.09. That is to say, x that is equal to 3.09 is shorter than the hypotenuse AP, therefore we verified that it is possible. So that answer is the correct answer. The area, because x is less than hypotenuse AP, that is equal to 5 units. So the area of square ABCD equals to 9.5775 square units. We finished with the first question, then I presented to you the second question. In the second question, in the drawing we have a right triangle ABC. Inside the right triangle we have a circle. Inside the circle we have triangle DOE, and our mission is to find out the size of this angle, angle theta. We know that AD equals to EC, and DE is twice as long as AD, and DE is also twice as long as EC. Again, our mission is to find out the size of this angle, angle theta. Now it is given as a question that AD equals to CE equals to DE over 2. So we defined line segment DE is 2A, DE equals to 2A according to our definition, and according to what is given as the question, AD equals to CE equals to DE over 2. According to our definition, DE equals to 2A, so we substitute DE by 2A, and we got here AD equals to 2A over 2. 2A over 2 is A. So we found out that AD equals to CE equals to A. That is to say, AD equals to A, and EC is also equals to A. Then I presented to you rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. The perpendicular OM from the center of the circle bisects chord CD. That is to say, CM equals to MD, CM equals to CD over 2, and MD is also equals to CD over 2. We implemented rule number 4 in our drawing. In our drawing, the center of the circle is also from point O, we draw perpendicular OT. According to rule number 4, the perpendicular OT bisects chord DE. That is to say, DT equals to TE, that is equal to DE over 2, and TE is also equal to DE over 2. So here, DT, according to rule number 4, DT equals to TE, and TE equals to DE over 2, and DT is also equals to DE over 2, because chord DE has been bisected by the perpendicular OT. Okay, so DT equals to TE equals to DE over 2. DE is 2A, so here we have 2A over 2, that is A. So in conclusion, we found out that dt equals to te equals to a. So dt equals to a, and te is also equals to a. Okay, then from point we define the center here. We define the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BC with this circle as N. We join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of the circle that is equal to R. We have the radius OM that is drawn to the point of tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Likewise, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. We have the radius ON that is drawn to the point of tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Inside quadrilateral OMBN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So, quadrilateral MOBN that has 4 right angles is a rectangle. Here, quadrilateral MOBN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN, but here MO equals to R. MO equals to BN, we found out that MO equals to R, so for this equation R equals to MO equals to BN, we will derive that BN is equal also to R. And BN is also equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that ON equals to MB. OMB equals to ON. But here, we have only found out that ON equals to R. ON equals to R. And from this equation, MB equals to ON equals to R, we will derive that MB is also equals to R. So actually found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to each other, they are equal to R. Then I presented to you rule number 10. According to rule number 10, if we have, according to rule number 10, if we have this circle and we have the external point, point P, from point P we have tangent PA, that is tangent to the circle at point A, and we have the straight line that intersects with the circle at point B and point C. So if this is the data that has been given to us, then the following equation is true, that PA square equals to PB times PC. Again, PA square equals to PB times PC. We can implement rule number 10 in our drawing, because in our drawing, if you focus on the external point C, from point C we have tangent CN, and we have a straight line, this straight line that intersects with the circle at point E and then point D. Therefore, according to rule number 10, we get that Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. I repeat again, according to rule number 10, at point C, we get that Cn square equals to Ce times Cd. Ce equals to A, so we substitute C here, Ce equals to A, so we substitute Ce by A. What is the value of CD? CD equals to A plus A plus A, that is 3A. So we substitute CD by 3A, in conclusion found out that Cn square equals to A times 3A. That is to say, Cn square equals to A times 3A is 3A square. So we took a root out of this equation and found out that Cn equals to the square root of 3A square is square root of 3 times A. So Cn equals to square root of 3 times A. Likewise, we focused on the external point, point A. From the external point, point A, we have tangent AB, and we have this straight line that intersects with the circle at point D and at point E. Therefore, according to rule number 10, we get that AM squared equals to AD times AE. Again, AM squared equals to AD times AE. Repeat again. The extra point A, according to rule number 10, we will get that AM squared equals to AD times AE. So AM squared equals to AD. Here AD equals to A. So substitute AD by A. And what is the value of AE? AE equals to A plus A plus A, that is 3A. So we substitute AE by 3A. We found out that in conclusion that AM squared equals to A times 3A, that is 3A squared. So we found out that AM squared equals to 3A squared. We took out of this equation and we found out that AM equals to the square root of 3 times A. AM equals to the square root of 3 times A. Then I copied the right triangle ABC in the new page and we analyze triangle ABC. Here, this is the triangle ABC that I copied from the original drawing. In triangle ABC, what is the value of the approach AC? AC equals to A plus A plus A plus A, that is 4A. What is the value of AB? AB equals to square root of 3 times A plus R. And BC also equals to square root of 3 times A plus R. So here, so we have this triangle that I copied from the original drawing, triangle ABC. So here, side AB equals to side BC because both sides are equal to square root of 3 times A plus R. And we know that in front of equal sides in the triangle there are equal angles. So in front of those two sides we have those two angles. So those two angles must be equal to each other because of the fact that they are located in front of equal sides. So if one angle is theta, then the other angle must be also equal to theta. And this angle equals to 90 degrees, so those two other angles must be also equal to 90 degrees in order to complete the sum of the angles in triangle ABC to 180 degrees. Those two angles must be equal to 90 degrees. So we found out that theta plus theta must be equal to 90 degrees. Theta plus theta is 2 theta. So we found out that 2 theta equals to 90 degrees. We divided this equation by 2 and found out that theta equals to 45 degrees. Here, theta equals to 45 degrees. Then in this right triangle ABC, it is very easy to see that cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R. This plus R. Okay. And AC equals to 4A. So we substitute AC by 4A and we substitute BC by square root of 3 times A plus R. Cosine 45 degrees is 1 over square root of 2. So we substitute cosine 45 degrees by 1 over square root of 2. And it is equal to square root of 3 times A plus R over 4A. Here we multiplied this equation by 4A and found out that 4A over square root of 2 equals to square root of 3 times A plus R. Then we substitute 4 by 2 times 2 and we found out that 2 times 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we substitute 2 by square root of 2 times square root of 2 and we got here that 2 times square root of 2 times square root of 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we have square root of 2 in the numerator and square root of 2 in the denominator, so to square root of 2 we get cancelled and we left only with 2 times square root of 2 times A, that is equal to square root of 2 times A plus R. Here we subtracted square root of 3 times A from this equation and found out that R equals to 2 times square root of 2 times A minus square root of 3 times A. Here we took A as a common factor out of this equation and found out that R equals to, so A is a common factor. what is left from 2 times square root of 2 times a after we took from it a is a common factor. What is left, it is actually 2 times square root of 2. And what is left from minus square root of 3 times a after we took from it a is a common factor. What is left, it is actually minus square root of 3. So in total, in conclusion, we found out that the radius of the circle equals to a times 2 times square root of 2 minus square root of 3. Okay, then I copied the right green triangle DTO in a new page, and we analyze triangle DTO. So this is the right triangle DTO that I copied from the original drawing. Here, point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to R. dt equals to A according to what we have already found out. This angle equals to 90 degrees according to our construction, and this angle is angle theta, the angle that we are looking for. So in this right triangle DOT, it is very easy to see that cosine theta equals to dt over OD. Cosine theta equals to dt over OD. dt equals to A, so we substitute dt by A. dO equals to R, so we substitute dO by R. And found out that cosine theta equals to A over R. So cosine theta equals to A, and we have only found out that R equals to A times 2 times square root of 2 minus square root of 3. So we substitute R by A times 2 times square root of 2 minus square root of 3. Here we have A in the denominator and A in the denominator, so A will get cancelled, we will left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. So our mission is to find out the value of theta itself. In order to find out the value of theta itself, we will operate the opposite function of cosine, that is cosine minus 1 on the result, and this way we get the size of angle theta. Okay, again, I repeat again, we operated the opposite function of cosine, that is cosine minus 1 on the result, that is 1 over 2 times square root of 2 minus square root of 3, and this way we got the value of theta itself. The value of this expression, that is to say, the opposite function, if we operate it on 1 over 2 times square root of 2 over square root of 3, we get that theta itself is equal to 24.203 degrees. So in conclusion, we found out that the side of this angle theta is equal to 24.203 degrees. Okay, and this is actually the answer to the question. And in the first question, we found out that the area of the square ABCD equals to 9.5775 square units. Okay, and here angle theta equals to 24.203 degrees. Okay, thank you very much.